In this lesson, we're going to look at the definition of b to the 0 power. What does that mean? What does it mean when we have an exponent that's 0? And then we're going to look at what it means when the base is being raised to a negative power. So in all the problems we've done in the past, if you look at every single problem, all of those exponents, if you look at them, were positive integers, right? 5, 7, 2, 3, 2, 4, 3. They were all positive integers. You don't see any of those exponents being negative. You don't see any of those exponents being 0, but they do exist. So we got to talk about, well, what do we do if we have an exponent that's 0, and what do we do if we have an exponent that's negative? It's a very simple process. It's not difficult at all. So let's go to the first one. So the first one we're going to look at is this definition of b to the 0 power. So to talk about the definition of b to the 0 power, we're going to look at a pattern. So here's a pattern we're going to look at, and then you're going to see what b to the 0 power is. Okay, so if I have 3 to the third power, you all know that 3 to the third power means 3 times 3 times 3, which is 27, right? If I have 3 to the second power, 3 to the second power means 3 times 3, that's 9. Now notice the base is 3. So all these bases that we're going to look at in this pattern is going to have the same base, 3. So if I have 3 to the first power, that's just 3, right? And I want you to notice that to go from 27 to 3, your base is 3. So to go from 27 to 3, I'm going to divide by 3. 27 divided by 3 is 9. 9 divided by 3 is 3, right? And continuing on with this pattern, I want you to see this. So 3 to the 0 now. So that's that 0 that we're talking about. Well, what is 3 to the 0? Well, if you continue that same pattern, 3 divided by 3 should be what? What's 3 divided by 3? 3 divided by 3 is 1. So by definition, now remember, your base cannot be 0. So any real number raised to the 0 power is going to be 1. So here's a definition of b to the 0. Definition of b to the 0. Okay. So first of all, your base has to be a non-zero real number. So it's any real number but 0. So b is a non-zero real number. So your base can be any number but 0. So by definition, then b to the 0 power equals 1. That's definition. B to the 0 power equals 1. So let's do some examples with that, and then we'll talk about, well, what do we do if it's negative, if the exponent is negative? So b to the 0, we know if the base is non-zero, if the base is not 0, then any real number raised to the 0 power is 1. Okay? All right, but remember, the base cannot be 0. So let's look at these examples. The first one's easy. Number 1. And the directions are going to say simplify. All right, simplify. All right, first one. What if I had 6 to the 0 power? All right, 6 to the 0 power. Well, by definition, my base is not 0, right? So 6 raised to 0 power is going to be 1. And then watch, just to show in your calculator, look in your calculator. Do 6 raised to the 0 power, you get 1. All right, so 6 raised to the 0 power is 1. What if you had this? Number 2, what if you had negative 3 to the 0 power? Well, same thing. Your base is negative 3. It's not 0. Your base is negative 3, and we now know that any real number raised to the 0 power is 1. All right, now be careful with this one. What if you had negative 3 to the 0 power? Now be careful. Don't see, those are different. The base here is negative 3 because it's in parentheses. See, there's no parentheses there. Okay, there's no parentheses. So you got to look at the fact that the only number that's being raised to 0 power here is this 3. Okay, so you may want to rewrite this like this then. All right, So we write like this. And so 3 raised to 0 is 1, so this becomes a negative 1. There's your answer, negative 1. So be careful. Notice the difference between 2 and 3. Okay? All right, let's go to number 4. And number 4, let's suppose we had, let me rewrite it this way. Let's suppose we had x to the 0 power. All right? Well, as long as x is not 0, then this variable expression, as long as x is not 0, then that's going to be 1 as well. So x to the 0 power is 1. So we're going to assume in all these problems that when you have variables, the variables are not going to be 0. They're not going to be represented the real number 0. Okay, 5. What if you had 2x to the 0 power? Well, what's your base? Your base is 2x. All right, and so any expression, as long as, remember, your variable is not 0, any expression raised to 0 power is going to be 1. What if you had this? 3 times 4x squared raised to the 0 power. Don't make it difficult. Be careful. All right, don't automatically say that's 1, because remember, what is being raised to 0 power? Only what's inside that parentheses, right? So 4x squared to the 0 power, that's 1, right? So that's 1, but that's being multiplied by 3. So 3 times 1 is 3. So be careful. Analyze what you're looking at first before jumping to any conclusions. Analyze what you are looking at first, okay? All right, so I think we are okay with the definition b to the 0 and the different types of problems you could see with it. All right, so any real number raised to 0 power, if it's not 0, is 1. And that's what we used in all these cases. Okay? Now, let's go ahead and start looking at, well, what if you have a negative exponent? All right, so let's consider that. Okay, so to talk about the definition of b to the negative n power, where the exponent is negative, let's look at that. Let's look at a pattern again. So we know that 3 cubed is 27. We know that 3 squared is 9. And remember, each time I divided by 3, didn't I? We know that 3 to the first is 3, right? 9 divided by 3 is 3. We know that 3 to the 0 is 1. 3 divided by 3 is 1, right? But what about this now? What about 3 to the negative 1? So notice the exponents, 3, 2, 1, 0, negative 1. So if I continue the pattern, then that means I take 1 and do what to it? I divide by 3. Well, 1 divided by 3 is 1/3, right? 1 divided by 3 is 1/3. And if you continue the pattern, look, if you continue the pattern, then I take 1/3 and divide by 3 as well. All right, well, let's think about that. Be careful now. So 1/3 divided by 3, right? That's what this says, 1/3 divided by 3. Well, 1/3 divided by 3, remember when you divide fractions, you take the fractions in the numerator and multiply by the reciprocal of the denominator. So the reciprocal of 3 is 1/3. Well, 1/3 times 1/3 is 1/9. So this is 1/9, right? That's 1/9. And we could do the next one, 3 to the negative third. So I take 1/9 and I divide by 3. So 1/9 divided by 3. Well, 1/9 divided by 3 means 1/9 times the reciprocal of 3, which is 1/3. 1 times 1 is 1. 9 times 3 is 27. So that becomes 1/27. Okay? And so I want you to think about what's happening. Okay? I want you to think about what's happening. So you see where I have 3 to the negative second is 1/9. See that? 3 to the negative second is 1/9, and then 3 to the negative 1 is 1/3, and 3 to the negative third is 1/27. I want you to think about what's happening right here. So if I take 3 to the negative 1, right, and we know that that's equal to 1/3, so 1/3. If I take 3 to the negative second, we know that's equal to 1/9. If I take 3 to the negative third, we know that's equal to 1/27, correct? Okay. Look at 9 right here. Do you all agree that 1/9 means the same thing as 1 divided by, well, 1/9 means the same thing as 1 divided by 3 squared because 9 is 3 squared? Okay, and then 1 over 27, I can write 1 over 27 as 1 divided by 3 cubed, because 3 cubed is 27. So you see this right here, this pattern? So look carefully. 3 to the negative third, if I want to make that exponent positive, I'm going to put this expression in the denominator with the exponent being positive. So 3 to the negative third means 1 over 3 cubed. 3 to the negative second means 1 over 3 squared. Notice a positive exponent. Negative 2 becomes positive 2. Negative 3 becomes positive 3. 3 to negative 1 means 3 to the first, right? Negative 1 becomes positive 1. So that brings us to this pattern. So this pattern right here, this pattern suggests the following, okay? Suggests the following, that 3 to the negative n, so if my exponent is negative, is just 1 over 3 to the n. So 3 to the negative n is just 1 over 3 to the n. 3 to the negative 2 is 1 over 3 squared. 3 to the negative 3 is 1 over 3 cubed, right? That's what this pattern suggests. So in terms of our definition now, in terms of the definition, and here's the definition of b to the n. So in terms of our definition, b to the negative n, we're going to say this. So again, as long as b is not 0, so b is a non-zero real number, okay? So I can rewrite this as 1 divided by b to the n. So that's the definition of b to the negative n. Now, keep in mind also this fact. 1 over b to the n, this right here is equal to this, but I can also think of this as 1 over b to the n power as well. Okay, because look, 1 to the n is 1, b to the n is b to the n. All right? Okay, so that's where we're at. Now let's look at some examples. So we're going to write these as examples. Okay, so before we do the examples, let's look at something that may cause some of you some issues with regards to what we're looking at. Many students think that what this is saying here is that I take the reciprocal of what you see. So b to the negative 1, they think, well, I'm going to take the reciprocal of that. Well, b to the negative 1, negative n, I'm sorry, b to the negative n is 1 over b to the n. That's not what that's saying, okay? So you got to think about this. What this is saying is that you're going to take the base of what's being raised to the negative power. So negative n, the base is b, okay? That is what you're going to take the reciprocal of. So the reciprocal of b is 1 over b. And then 1 over b raised to the n power is this. All right, so that's important to understand. So in other words, if you have this, consider a divided by b raised to the negative n power. So what's being raised to the negative n power? It is this base right here. My base is a divided by b. So if I want to make this exponent positive, I've got to take the reciprocal of the base. And the reciprocal of the base is b over a, and now that becomes to the n power. Okay, so be careful. And you're going to see what I mean in a little while. So this definition says you take the base of what's being raised to the negative power. You don't take the reciprocal of this whole expression. It's only the base. What's being raised to negative power is just b. So I'm going to take the reciprocal of b, which is 1 over b, and then the sign of the exponent changes. So negative n, positive n. And then this right here is the same thing as this. 1 to the n is 1, b to the n is b to the n. Okay? So that's going to be important as we go through these. So let's look at some examples. And direction to say simplify. So number 1. So number 1, what if we had 5 to the negative second power? 5 to the negative second power. Well, according to our definition, first of all, I need to look at what's being raised to the negative second power. So what is that base? That base is 5, right? So now to get this exponent to be positive, you want to make it positive, to get that exponent to be positive, I'm going to take the reciprocal of the base, which is 5, then reciprocal of 5 is 1/5. And that is being raised to the second power. And then I just simplify this. 1 to the second power is 1. 1 squared is 1. 5 squared is 25. And that's it. Okay, that's all you do. There's your answer. It is not a difficult concept, right? It's fairly simple. So let's look at this one. Number 2. Let's suppose we had a raised to the negative 4th power. So I want to make that exponent positive. In order to make that exponent positive, you got to think about, well, what is the base? The base is a. Base is a, because that's what's being raised to the negative 4th power. So then I'm going to take the reciprocal of a. The reciprocal of a is 1 over a, and all that's being raised to the 4th power, right? And so 1 to the 4th is 1, a to the 4th is a to the 4th. So the answer is 1 divided by a to the 4th. Not difficult at all, right? Very simple process. Okay, number 3, what if you had negative 2 raised to the negative 4th power? Negative 2 raised to the negative 4th power. Well, according to our definition, to make this exponent positive, I need to take the reciprocal of the base. The reciprocal of the base is, in parentheses, 1 divided by negative 2, or negative 1/2, right? And that's being raised to the 4th power now. Well, according to properties we know, I can take the numerator, raise it to, remember the power of a quotient, So take the numerator, raise it to the 4th. Well, 1 raised to the 4th is always 1. The denominator is negative 2 to the 4th, right? But be careful, negative 2 to the 4th should be a positive number because a negative raised to an even power is positive. So when you do that, negative 2 to the 4th, negative 2 times a negative 2 is a positive 4. Positive 4 times a negative 2 is a negative 8. And a negative 8 times 2 is a positive 16. So you have 1 divided by 16. Okay? And then if you use your calculator, just to show you, make sure you put negative 2 in parentheses. So look, negative 2. All right, negative 2 in parentheses. Negative 2, close the parentheses, raised to the 4th, you get 16. All right, so there's the answer, 116. Leave the answer as a fraction. Don't use decimals. Don't use decimals. So there's the answer. Okay, it is not difficult at all. Okay, so let's look at this one. So using that same idea, what if you had this, though? What if you had 1 divided by 5 raised to the negative 2nd power? Think about what we're talking about, right? If I want to make that exponent positive, then I got to think about the base. What is the base? The base is 1/5. What's being raised to this exponent? 1/5. So I got to take the reciprocal of that. To make that exponent positive, I got to take the reciprocal of this. Well, what is the reciprocal of 1/5? Well, the reciprocal of 1/5 is 5, right? And so now I get 5 squared, change the sign, and 5 squared is 25. See how simple that is? It is not difficult at all. Just think about taking to make this positive, you got to take the reciprocal. Okay. Number 5 is very simple process. Okay. So what if you had negative 2/5 raised to the negative 3rd power? Same idea, right? I want to make this exponent positive, so guys, I have to take the reciprocal of this base. Well, the reciprocal of this base is going to be a negative 5/2. So it'll be a negative 5/2 cubed. And then now all I do is take the numerator. So I'm taking the power of a quotient. So I'm going to take the numerator, raise it to the 3rd power, and then take the denominator and raise it to the 3rd power. See that? And then negative 5 to the 3rd power, be careful. Make sure if you can't do it real quickly by hand, use your calculator. But negative 5 times negative 5 times negative 5 should be a negative 125. And then 2 to the 3rd, 2 times 2 times 2 is 8. Leave your answer as a fraction. Okay? Don't use a decimal. All right, so that's number 5. Let's look at number 6. So it's not difficult at all. Not difficult at all. Okay, so some students have trouble with something like this, where the exponent is negative in the denominator, just like we see. What I would do is still use that same concept we've been talking about, that same idea. So look at what's being raised to the negative power. What is being raised to the negative power? And that's what you ask yourself. Well, what's being raised to the negative power is this x to the negative fifth, right? And so if I want this exponent to be positive, I got to take that base and take the reciprocal of that. So the reciprocal of x is 1 divided by x. So here's what you have, though. You have a numerator. So you're going to say 1 divided by, and then in parentheses, you're going to say 1 divided by x to the fifth. Okay? Just like that. And then what I would do is I would then do this. I would say 1 divided by, and then you have this. You have 1 to the fifth, which is 1, and then x to the fifth, which is x to the fifth, right? Just like that. And then you have a fraction divided by another fraction. So you're going to take the numerator and then multiply by the reciprocal of the denominator. So 1 divided by x to the fifth is x to the fifth. So you get x to the fifth as the answer. Okay? But here's the quickest way to do this, though. So it's a pretty long process, but that's the idea of using our definition, that idea we've been using. So here's what you got to remember. And this is a shortcut, students, remember. If the exponent is negative in the denominator, you bring it to the numerator. Okay, so then they'll think this. They'll say, all right, so I have the numerator, which is 1, though, right? So it'll be 1 times, and then to make this exponent positive, it's negative in the denominator, so I'm going to take this whole thing and bring it to the numerator. So I get x to the fifth, so 1 times x to the fifth is x to the fifth. So that's another way you can think about that. Okay? So for example, if you had this, look carefully. If you had 2 divided by x to the negative fifth. 2 divided by x to the negative fifth. So remember what we said earlier, misconceptions that students think that they take the reciprocal of this whole thing. You don't. Okay? You don't take the reciprocal of this whole thing. You only look at what's being raised to the negative power. So what's being raised to the negative power is this x only. So 2 will stay where it is. 2 is in the numerator. So if I want to make this exponent positive and it's positive in the denominator, then I'm going to rewrite it in the numerator. I'm going to put this in the numerator. So I get 2 times x to the fifth. And there's your answer. 2 times x to the fifth. So number 8, what if you had 3 times x to the negative seventh power? What's being raised to the negative power? Well, what's being raised to negative powers is x. So I know that I'm going to have to, since in the numerator, I know I'm going to have to bring in the denominator. So I know that the answer is going to be 3 divided by x to the 7th, right? But that also brings us back to that definition. So if I want my exponent to be positive, I got to take the reciprocal of that base. Well, the reciprocal of x is 1 over x. I get 3 times 1 divided by x, right, to the 7th. And so that becomes 3 times 1 to the 7th is 1, x to the 7th is x to the 7th, and this becomes 3 divided by x to the 7th, which is what we had here. Okay? So try and make all those connections, all these ideas, that if the exponent is positive in the denominator, to make it negative, you bring just this part to the numerator. If it's negative in the numerator, then you just bring what's being raised to the negative power, negative exponent, to the denominator. So that's what you see here. So what if you had this? What if you had, let's say you had 1 divided by 2x to the negative 6 power. Don't make it difficult. Think about what you have. So if I have 1 divided by 2x to the negative 6, what's being raised to the negative power? The only thing being raised to negative power is this, right? So this is the only thing you're going to deal with. The 2 will stay in the denominator. So I have in the denominator I have 2. In the numerator I'm going to have 1 times this 1 is this 1, and then that's going to be x to what power? To the 6. So I get x to the 6 divided by 2, or you can say 1/2 x to the 6. Okay? Don't make it difficult. It is not supposed to be difficult. Number 10, you have 3 divided by 5x y to the negative 2nd power. Okay, you want to simplify this. You don't want any negative exponents. So what's being raised to the negative second power? What's the only thing being raised to the negative second power? The only thing being raised to negative second power is this y right here, right? So this is what you're going to bring to the numerator. Everything else will stay where it is. So the answer is going to be 3y to the second divided by 5x. That's the answer. Okay, 11. Let's look at 11. What if you had 4x to the negative fifth power divided by 2y? What's the only thing being raised to the negative power? The only thing being raised to the negative power is this x. So that's the only thing you're going to bring, this expression, the only thing you're going to bring to the denominator. It's in the numerator, you're going to bring it to the denominator. So it becomes 4 divided by 2x to the fifth y. There's your answer. Notice all the exponents are positive. Okay? All right, so that's where we are so far. It's not difficult at all. Just think about what you're dealing with. All right, so let's look at that one. So that one's easy to do. Just you can easily use the definition. So I have this base, which is 4x, is being raised to the negative power. So I know I can just take the reciprocal, right? So the reciprocal of 4x is 1 divided by 4x raised to the third, just like that. And now power of a quotient. So I have 1 to the third, which is 1. And then 4x to the third, right? Well, remember what 4x to the third is. 4x to the third means 4 to the third, x to the third. And then use your calculator. 4 to the third, 4 times 4 times 4. So 4 times 4 is 16, and then 16 times 4 is 64. But you get to use your calculator to get that. See 64? So the 64x cubed. So this is 64x cubed. So this is 1 divided by 64x cubed. But then you also know, well, I can do it the short way as well, because you can think of this as divided by 1. So what's being raised to the negative power is just 4x. So I'm going to put that in the denominator. Now be careful. So you have this, right? Which is what you see here. But then you might say you need to understand, well, what's going to be in the numerator? Well, be careful. There's no number right here, so that's understood to be a 1 right here. So that's going to be 1 in the numerator, okay? And that's what you see here, that 1. And then, so this becomes 1 divided by 64x cubed, right? So for that one, though, most students seem to understand it better for something like number 12 if they do it this way. Think about, well, what does that really mean? An expression raised to a negative power means that to make that power positive, I've got to take the reciprocal of that expression, okay? Okay, so in number 13, what do you think is the answer real quick? What do you think it is? So if you had a few seconds to get that answer, what do you think it is? Okay, so if you said the answer is -8 divided by x to the fourth, you're correct. That's the answer. So let's think about what's being raised to negative power. The only thing that's being raised to negative power is this x. All right, so I got to take. So if you do the long way, you got to take the reciprocal of that base. So that'll be -8 times 1 divided by x to the fourth. That's what that means, right? And then using the power of a quotient, this becomes -8 times 1. 1 to the fourth is 1. And x to the fourth is x to the fourth. And then writing it as one fraction, I get -8 divided by x to the fourth. The other way you could think about it is that this expression here that's being raised to negative power is in the numerator. To make it positive, to make that exponent positive, I've got to bring it to the denominator. So you could have gone from here to here real quick. Okay, so I think that we are good with those two definitions. So what we did in this lesson was we looked at the definition of b to the 0 and then b to the -n. And then we just saw some examples. We understood that definition by looking at the patterns. So once we look at the patterns, you then understood what it means when we see b to the 0 and then b to a negative exponent. So in our problems, though, whenever you see a negative exponent, you want to make it positive. So you have to use your properties for negative exponents. Okay? All right, so that will be the end of this lesson.